tell me when I'm on. All right. Let's do this. I'm ready. Come on.
Yeah, I think there are a lot of startups like moving fast in this space, and they're not going to be like.
Hello.
Crossing.
Welcome, everyone. We're super excited to have you here. This is our first meetup ever in London, and hell yeah! And this is actually our biggest event ever that we've done. When we first announced it, I expected 50 people to come. Then we got 500 people registered, and finally we ended up with, I think, about 1,000 people, which is insane. Thank you guys for joining us. We have some really exciting things to show you tonight. We're going to start with some product announcements. Then you'll hear from Emad from Stability, Nuno from LangChain, and then we also have some really exciting surprises for you guys backstage. But first, I want to tell you a little bit about how you can be a part of the Weights and Biases community. So if you like what you see today, if you like the people that you meet, I would love for you guys to join our Discord. You can find it at that link right there. Our Discord is full of machine learning practitioners who are really helping each other. That's the core of our community. We really want anyone to be able to join us. And then we want everyone to be helpful to other machine learning engineers in there and help everyone get better, you know? This is a community we're super proud of building, and we really hope that you join us. Next up, we also believe that machine learning should be accessible to everyone, and also learning machine learning should be free. So we've been creating all of these different courses to help machine learning engineers learn to put their models in production. And in these courses, we share best practices that we have learned from working with some of the best machine learning teams for years. And you can find them at 1b.me/courses. We also have Fully Connected, our blog. Anyone here heard of Fully Connected? There's one person, hell yeah. I love a new audience. So Fully Connected is our blog. You can see it on the left. So this is full of tutorials that are written by machine learning engineers just like you on the most important topics of the day. So if a new model comes out, you can probably expect a deep dive on it on Fully Connected in the next few days. And you can find it at 1b.me/fc. Also, we love throwing events, as you can probably tell. And we run about 4 to 8 events a week. My events team is insane. They're in the crowd, and they work really hard. A lot of these events are virtual, so you guys can all join them, and you can find them at 1b.me/events. But that's not all. So we're super excited to announce that we're hosting our first ever user conference in San Francisco in person on June 7th. We don't have a sign-up page just yet, but if you watch our social media, we're going to post the link to it there soon. And finally, we also have a podcast that we're super proud of. It kind of started as a joke between me and our co-founder, and it's been going on for 3 years now. So our podcast is where Lukas, our CEO, takes you behind the scenes to learn from industry leaders like Jensen, the CEO of NVIDIA, about how to put your models in production. And you can find it at Weights and Bias at 1b.me/gd. And speaking of the host, I would love to welcome our co-founder on stage.
All right. Yeah, guys, yeah. What an exciting night. I can feel a real buzz in the air, you know? Oh boy. Some of you might be asking, why is there a grown man wearing a bee costume up on stage right now? Just know I'm asking myself that same question. Let's get this night started by doing a little audience participation. How many folks have used Wand Bee? Make some noise. Oh yeah, all right. What about LangChain? We got any LangChain users out there tonight? All right, yeah. Stability.ai fans, maybe. Can we make some noise? All right. All right, let's try this. Everyone that likes TensorFlow, say, hey! PyTorch, ho! Yeah? Okay.
Okay, that's enough of that.
Yeah, okay.
That's the wrong co-founder. I actually wanted to welcome Lukas Biewald, our CEO, to tell you about some interesting product announcements.
Awesome. Did you just walk off with the clicker? Nice. It's so awesome to be here. This isn't exactly what I thought I was signing up for, doing a meetup in London, but this is so much better. I was actually in San Francisco a few weeks ago for Hugging Face's awesome Woodstock AI event, I guess, and it's been, that was an amazing event and I loved it, but it's been almost even more exciting to walk through the audience here and just see what you all are up to. It's amazing. I really appreciate it. I'm CEO of Weights and Biases. I'm Lukas Biewald, and I'm here to talk about weights and biases for LLMs. Do you have the clicker? I can use the laptop. No worries. And since a lot of you actually hadn't used weights and biases, before we get into weights and biases for LLMs, I just wanted to go through what weights and biases does. And our mission has always been to build the best tools for machine learning practitioners. And we define machine learning practitioners broadly as anyone that's trying to make machine learning models work in the real world. That's how we've always thought about it. And so the history of the company in a nutshell, it's actually been 5 years and things have changed a lot. We started off, it was just me and that bee and a third co-founder who's back in San Francisco working really hard on the next products. And we built a thing called Experiments that was to help people, including ourselves, do experiment tracking. So keep track of all the models that we were building and kind of understand where they regressed and understand how to make them better. And not long after we built this, people asked, hey, could you help us make a system to make models automatically better? And so we built Sweeps, which is a hyperparameter tuning system. Thank you. Awesome. And then not long after that, people said, well, we really want to share the stuff that we're doing with colleagues and, our boss, and then eventually actually the whole world. And that was Reports that we built. And then people started saying, we really want full reproducibility here. We want to track not just the model architecture, but the training data that went into the models, and that's complicated because it's changing all the time. And so we built a thing called Artifacts. Then folks wanted to explore data, so we built tables. They wanted to track things in production. So recently, this is actually just a few months ago, we launched models. And then our most recent launch to date is something called Launch, which came from people asking, can I actually automatically run jobs from the Weights and Biases interface? So it's always been guided by requests from people like you who were using machine learning and had problems they were running into and were talking to us and telling us, hey, here's a new thing that I need. But today we're here to talk specifically about LLMs, which we've been thinking a lot about inside of Weights and Biases. And just from talking to all of you, I know that you've all been thinking about it too. And to kind of ground this in our perspective, we think there's sort of 3 ML practitioner types, and you may be all 3 or just one of these. The first is large language model creators, right? So these are folks that are training LLMs from scratch, these big models. These are kind of hardcore machine learning people. The second is the LLM fine-tuners. So these are people that are taking models and adding a little bit more data to do something interesting with them. And then finally, the LLM prompt engineers who use LLMs as an API or a service and try to figure out how to interact with that LLM to make something useful happen. And these days, prompt engineer could be almost anyone. So I wanted to start a little bit with what we do for LLM creators. And these companies and organizations actually all build LLMs, and they're all longtime customers of Weights and Biases that we feel super proud of. Actually, large model training was our very first use case in our bread and butter. This is us at OpenAI back in 2018 when it was really just a handful of people, and we were just a handful of people. And this is our first product manager, Carrie, talking to Peter over there. And Peter's actually showing a very first iteration of a Weights and Biases dashboard, which I think we knew we were onto something when OpenAI decided to take that dashboard and kind of put it on their wall there. That was really a joy to see that. We had about 10 users at the time, and I think 9 of them were inside of OpenAI. And so at that time, they were talking about scaling infrastructure for large models. And you go back to 2018 and they were thinking, wow, we're going to need so much more infrastructure to make these models work. And they were totally right about that. But another thing that they were talking to us about is actually scaling the teams to build these large models. And this is actually the very first case study we did, also back in 2019, I believe, where they say, you know, when we have 10 to 20 people working with our code base, at any point someone could commit a change and break something, right? And that's what I really, really wanted to help them with that. And it's been so exciting to see so many other organizations kind of get to the point where they have 10 people or 20 people trying to build something together, trying to build a machine learning thing together, and then you run into these things. And it's funny because, you know, back then, 10 seemed like a lot of people to work on a model together. And then, you know, these organizations like Meta or Facebook Research Labs became hundreds of people. And now with the way Stability is working and other organizations kind of in public and letting anyone in, these teams are practically speaking thousands of people working together, all trying to make models better. And so one really exciting trend here is the open sourcing of models, and Stability has absolutely been at the forefront of this. But we first saw it with DALL-E Mini, which was an open source version of DALL-E, where the author of this kept a training journal. And it's like hundreds and hundreds of pages of Weights and Biases logs of every single thing that they did. And it's actually really interesting to watch his process as he learns how to do this. And then the next one we saw is Luther doing public experiment tracking on GPT-J and NeoX, completely in public, completely where everyone could see it. And you can actually follow this link right now and look at kind of the evolution of all of these models. And lately we've seen things like OpenAssist, which just came out and is really exciting. And of course, Stable LM, which was released yesterday, I believe. So good timing for this event. But also something that we feel really proud to have helped in a little way with. So training LLMs is not a small feat, and I would not undertake it lightly, and I don't actually recommend it to most of our customers, but we did want to offer a little bit in the way of helping people that insist on doing this, and it's surprising how many people insist on trying this. We have a white paper at LLM White Paper. We've kind of combined all the sort of best practices that we've seen across different types of organizations that want to spend millions of dollars on compute and hire kind of the hardest to hire people and bring them together to train an LLM from scratch. But now, I think the most exciting trend in the last couple of years for us has been LLM fine-tuning. And this used to be a research topic. I think, you know, back in the aughts, lots of people talked about fine-tuning, a lot of papers on fine-tuning, but most companies didn't do it, right? And this is where you take an existing model and you kind of use the fact that it's been trained on lots of data, but then you take it and you feed in a smaller set of your own data. So you get the kind of power of the LLM, but you've made it unique to your use case. And it works super, super well, right? Lots and lots of people do it, but I think it was hard to do until Hugging Face came along and made it incredibly easy, just a few lines of code, to take existing large models and then fine-tune them. And also they made a place where people could publish these models. So tons and tons of models on Hugging Face. It's an amazing product. And so we built a zero-line integration a long time ago. So actually all you have to do is import WanDB, and then you get these nice little dashboards. It's much less of an engineering undertaking for us to ingest all this data. So we appreciate when people fine-tune instead of building from scratch. We can make these graphs with almost no cost to ourselves, and we love it, all the people that do it. And I think like all these same products that were sort of built for training from scratch, they work the same way for fine-tuning. You still often want to do hyperparameter searches over what's the best learning rate, what's the best batch size, what kind of data should I feed in. You still want to look at, what's the input data. In fact, the data lineage can get more complicated with fine-tuning as you kind of feed in different data as your model evolves over time. Tables and exploration is important for any application of machine learning, but it's especially important on text, right, where you want to look at what exactly is the model doing in specific cases, and everyone should use a model registry, even if you don't use weights and biases models, to keep track of the model lifecycle so you know actually what you're putting in production. The number of stories that I've heard of just sort of simple mistakes, including from Emad a few minutes ago, just blows my mind. You all should be using some kind of model registry no matter what you're doing. And kind of all this has been super exciting. We've actually tracked over 200 million hours of compute on weights and biases, and a huge boost to its popularity and the mainstreaming came from this fine-tuning on large language models. So we actually are announcing today, and I think this could be relevant to a lot of you, a free course that we're putting out on best practices for training and fine-tuning LLMs. So you're welcome to go here right now and sign up and register for it. It's completely free. Our courses get really good reviews, and it's made by experts in our community that have done this a lot themselves. All right, so the big thing that we've been thinking about, maybe the most exciting thing going on right now, which I think is contributing to why we actually had to turn away people from this event, which I gotta tell you, as an entrepreneur, turning away people from your own event, it just like breaks your heart. Like it like kills you. Like we got a bigger venue and then a bigger venue and we couldn't get an even bigger venue. So for folks on the live stream that couldn't actually sign in, I apologize. We'll get you in the next one. This is prompt engineering, right? And this is like the most popular way to use large language models right now. You don't fine-tune it, you don't build it yourself, you just take something off the shelf and then figure out how to make it useful. And I'm assuming almost all of you have fine-tuned something, but I don't want to be speaking past anyone. So what I actually mean by prompt engineering is you take a model and instead of building your own translation model like I would have done, and I actually did do in grad school, and that work that I did is completely irrelevant now. Instead of doing that, spending years of your life on that, you just ask the model, hey, could you please translate this from English into Italian? And then it does it beautifully. Amazing. Right? And then you can do things like solve almost every classical NLP problem just by asking a large language model, right? So sentiment analysis, another classic problem, you just say, hey, is this tweet positive or negative? Right? Instead of doing any classical machine learning or even deep learning. And then this actually does get subtle and interesting the second you try to really do this. So I think one of the most salient and kind of fun papers on this, some of you might remember this, right, is actually doing math question answering and logic question answering, where they started off by just asking the question, and then they added, let's think through this step by step, right? It actually causes the model to answer the question step by step, which amazingly causes the accuracy of the model to improve a lot. So that made GPT-3 go from kind of below state-of-the-art on some of these benchmarks to actually above the state-of-the-art. And I think this was part of a big explosion of new ways to actually frame asking models well to get the answer that you want. And so one question that I've been asking myself, and a lot of people have been asking me, is does building the best tools for machine learning practitioners still matter, right? This has been kind of our North Star since we started the company, and we've really had amazing success doing it. But you might wonder, we don't need a lot of the methods that a lot of us studied in school anymore, right? Like I think you wouldn't build a standalone translation system probably. You wouldn't build a standalone sentiment analysis system probably. Do we even need machine learning practitioners? And I guess the way I look at this, and maybe this is just optimism, I guess I argue that the market just massively expanded. I think every software developer, maybe every person now, can be a machine learning practitioner the way we defined it, in the sense that everyone can use machine learning models for real world applications without needing a lot of training. And so what we've seen, and you really, really feel this in San Francisco, let me tell you, in Silicon Valley, you just feel this so acutely. There's been an absolute explosion of generative AI companies. And the demos that these companies do are unbelievable. They're so powerful. I used a product called Tome AI the other day, and I typed in weights and biases sales pitch, and I got out a PowerPoint deck that was like a pretty good weights and biases sales pitch. I mean, just the number of like astounding demos is awesome. And some people might call it hype. I think there is a sense that this is hype, but I look at this, and I've been doing this a long time, and I've seen a lot of hype cycles. These companies really do useful things, and many of them use weights and biases, and we really want to support them in what they're doing. We think it's incredibly important, and we've been thinking a lot about this over the last couple months. How can we support these generative AI companies well? And so I'm actually super excited. It's such an opportunity. We've never really done a big product launch, and this is slightly accidental, but we're really doing it. We're actually really announcing kind of the biggest product launch that we've had in the company, which is Weights and Biases Prompts, which is our new LLMOps toolset. And so Weights and Biases Prompts includes a lot of new functionality, and I want to show it to you with a real-world use case that we really did. And this use case, which I love, I don't know if any of you have tried this, is generating SQL on a database from a question and a schema. And I've seen in like the last 20 years that I've been doing this, so many variations of this, and it's always so annoying, it's always so bad. It sounds good, right, to just type in text and query your data set, and it's always so bad. But in this case, it finally really works. We've really seen this, right? So here we're inputting our schema and a question, like find the ID of the first product we sent a customer. And what we're hoping for here is this kind of output where it's SQL, and then we're going to run the output. And so I don't know how many of you have actually tried this, but what this code looks like here is something like this. It's probably hard to read, but it's Python code where we have a prompt template, and we have a set of questions. And then we have a simple integration with OpenAI done through LangChain. And then we create a table of the results. And then actually the weights and biases integration is just this one line at the bottom here where it's logging what happened. So it's So here's each row here is a different question, and here's SQL that we're getting back from asking that question. And honestly, it looks pretty plausible, right? This is really run on real data. And then we're looking at these giant full model inputs because we're actually inputting the full schema. But we can go through this and look for bugs that we might be encountering. And then we're also tracking the model name and temperature. Because if there's one thing I've learned in my life, it's like you want to automatically write down the different things that you're doing. And prompt engineering is absolutely no different, right? A week from now, I'm going to wonder what I did, and I'm going to be so happy that this thing automatically logged the temperature of the model that I was using. So that seems like it's working, and then we actually really want to run it. So LangChain makes this very easy to do. So our first step in this LangChain iteration is generating SQL, and then the next step is we're going to execute that SQL. Okay, so what this looks like is actually we're going to show you the integration at the top here. It's a one-liner of just 1DB tracer.init. And what that does is it makes it automatically log everything that LangChain's doing. And so we're setting up a chain here where first it's asking the question, and then it's running the SQL that comes back. And here's where we feed in the questions, and we use a template, and we run the chain, and you can see that you get these cryptic errors here. And you know, LangChain, one of LangChain essentially founders is here today, so I'm not going to criticize this too much. It's really hard to make good error messages, but I think this is actually a lot clearer what's going on, even though this is still pretty complicated, right? So here's the string preview. So the question was get my last 10 orders. Here's the schema that we passed in. So this was both fed in to a template. And then I'm looking and I'm seeing there's no output. So what's going on? Right? I can that was created, and I can look at the error messages, and actually I'm getting different errors on different runs of this LangChain. And so you can go into this tracer, it actually looks a lot like a stack trace for the engineers in the audience, right? And it has two steps in that trace. So there's an OpenAI step where it's asking the question with the prompt. Here's my database schema, and here's my question. And if you look, you can see the output here is giving us a bunch of metadata, so a number of tokens and the tokens used, and then the transform chain step, which actually is running it, gives us an error. And in this case, the error is that the object is an iterable, and it turns out kind of a dumb error. In this case, the language model actually sent me empty data. And these are some of the weird quirks of the OpenAI integration. If you send it too short of a prompt or too long of a prompt, it can just error out and send you nothing. And then downstream, you get these bizarre errors that take you forever to debug. So again, we're just trying to solve the simple problems like that. And we're giving you a lot of easy access into everything that's going on. Most of it you'll never need, but when you do need it, you'll be happy that you had it. So then, here was the idea to make this better, right? So it turned out some of the SQLs malformed, and incredibly, the solution here was to generate the SQL, then go back and ask the same LLM, okay, you generated the SQL, could you please debug your own SQL and make it better? And then execute that SQL. So that's the new LangChain. I guess this is state of the art. And here we're creating these steps here. And you can see we're inserting the clean SQL chain, which says, please correct any syntax errors in the following SQL, which you actually just generated for me. And then you can see here that actually all these runs are successful. So the output is true. You can actually see, you can see that the inputs here are the same, but there's kind of this intermediate result. And it's asking, find the top 1 customers that have spent the most money. The sequels are here, really is real. And I'll tell you, this actually is the right output on this data set. So this model worked at least these 3 times that we are showing it to you here. And again, you can see actually a little bit more of a complicated stack trace because there's 3 steps here. You can see the output here is SQL, and look at that dot. For some reason, it put that period in there. Again, these like maddening little errors that are so frustrating to debug. And then it's going to pass that into this step where it sees that period and it takes it out. And actually, it cleans up the formatting slightly if you look closely, which I think is also kind of a delightful feature of that step. And then it runs it and gets a useful output. OK. So then the kind of final thing here is, what do you do when you want to explore what happened, right? So this is, I mean, I'm giving you the kind of fun debugging steps, right? But the reality is you try 1,000 things and you kind of like build up this big set of things that you tried, and you kind of then want to go back and look at, okay, what worked and what didn't. And actually in the case of LLMs, even working is a little bit ill-defined, right? It's often outputting something that's, you know, maybe sort of right, or you want to make a little bit better. And so we've built this really flexible table here, which you can query with essentially arbitrary code, right? You can do grouping and filtering. And so for example here, we're grouping by whether it's successful or not. So you can actually, even though these all look successful, we can find all the errors and see if we see patterns in the failures that are happening. We can also kind of create new columns that are created from other columns. So for example here, after the fact, we're creating a column which asks ourselves, does our prompt contain orders? Right? So it's saying, you know, some of our queries included orders, some didn't. We want to filter down just to those. So the ones that actually has orders are marked as true. And then we're going to group in the same way, kind of chaining together different steps here. And then we can analyze this data. So we're super excited about that. We've also built an OpenAI integration that looks almost the same as the LangChain integration, but has a slightly different structure. But again, one line to kind of automatically get all the information that happens as you do the OpenAI integration. And we've also created a way to quickly evaluate your models. And what we did here was we wrapped OpenAI evals, because so many people have been running into this question of, how do I know if my model is working or not? I showed you that I properly generated SQL, but did it give me the right answer? It's kind of an open question. I had a funny interview with the CEO of Repl. Weights and biases, but people are trying to get away from that. And OpenAI has built this really great framework, OpenAI evals, but many people haven't used it. And not because it's a bad framework, but I think people are busy and these integrations are hard. So what we wanted to do was build a very, very simple way to run OpenAI evaluations. And we do it here with our launch product, where we actually send something into a job queue. So you're basically taking your data set of the data that got generated, and we help you send it right into OpenAI evals, and we actually just run that for you. And so you get back these kind of beautiful charts where you can look at how well your different models are working, and hopefully know if your models are improving or degrading as you change your prompts. So we have one more demo, and actually I just want to say all these things that I'm showing you were made by engineers, mostly back in the SF office. They worked super, super hard on this, and this is, I think, really excellent. But for the last demo, we actually have the author of the demo, my co-founder, Chris, who built this to show it to you.
That's right. This bee can write JavaScript. We're releasing our JavaScript SDK for working with tools like LangChain and easily building apps. So it's npm install WNB SDK. There might be a couple bugs. Probably not, though. If there are, let me know. We'll fix it. Next slide, Luke. So this is it in action. You just paste 2 lines, very similar to the Python API. So you bring in the tracer, you write your LangChain, and you finish your tracer. In this case, we're doing a SQL generation task again. I have a database of a bunch of CDs and tracks. And we can ask the question like, what genres are the most popular, or which artist released the most tracks, or what goofballs zinged the most zoinks. I was trying to get it to not work, but it worked. It hallucinated. So here, yeah, we could see the SQL actually getting generated here, just like we did in the Python SDK. And if we refresh, we can finally get the answer to what goofballs zinged the most zoinks. The query orders by Zorks zinged, and the answer is Iron Maiden, U2, Led Zeppelin, Metallica, and Lost. So there you have it. Play with WNB SDK. Thanks, everyone.
All right. So in summary, we've just shown you a whole bunch of stuff. We've shown you improved flexible tables for doing language exploration. We've shown you a new prompt tracer. We've shown you a LangChain integration, OpenAI integration, a way to launch OpenAI vals, and a JavaScript integration. And I just want to say, none of this is vaporware. This is all live right now. If you go to this link, wnb.me/LLMs, you can actually use all this stuff immediately, and I really hope you use it, and I really hope that you find it useful. We're super excited to launch this.
Will you take me on that?
We're also, I have to say, we're really hard at work, and we have lots of ideas about what's next. But we love collaborating. And I'll give you a real world example. This user on Twitter is asking for an integration to 1DB sweeps from an LLM project. And our team jumped on this immediately. So we really are responsive, and we really are listening. And we'd really love to know what you need. So please come up to us and tell us what you need, or go to us on Twitter and ask us for things that'll make your life easy as you do LLM prompt engineering or build LLMs from scratch. Thank you. Back to Lavanya.
All right. I hope you guys are excited about the new product. Next up, we have Emad from Stability, who is going to give a talk.
Thank you very much. All right. Hi, everyone. Gosh, there's a few people here, eh? It's an exciting time. I don't think anyone's ever seen anything quite like this. I just found out today that it's not actually WandDB, it's WandB, and that's why there's a B with a wand. So my apologies for thinking it was a database. I always got a bit confused. No, really, thank you, Lukas, just for having me here. And I think, this is the key thing. It's magic, right? Any sufficiently advanced technology is magic. And I think we've all here kind of seen that. One of the things I was commenting on earlier is, does anyone know a single smart person that isn't excited and terrified by this? No, we all know it in our circles. Like, with crypto, it was like, well, there are people that are excited about it, but a whole bunch of people are like, eh. Whereas this is everyone. But it's a bit like no true Scotsman. If they aren't excited about it now, then they're not intelligent. So, that's a good test of all your friends, right? But even my mum's asking me about it constantly, not just because I'm a CEO. She's like, Emad, what's this? And look, she's like making me memes with the new image models saying, why don't you call me enough? Again, the superpowers that you have, I think, are going to be quite insane. So again, thank you all for being here. Let's see, do I just press this button? Hey, Stability.ai, there we go. End of the world as we know it. Oh, gosh. One of the ways I like to put it is that everyone's here because of a story. You all love kind of ML, or you're terrified by it, in which case, just please bother Lukas about it, because he's enabling it, not me. And that's how we kind of scale the society. We first of all, maybe if I step this way. First of all, we kind of told stories, and we had our tribe. We took the stories and we put them down. And that allowed us to scale even more. And it allowed us to create corporations and organizations with bylaws and constitutions. And organizations right now are slow, dumb AI. They are slow, dumb AI that has to make us legible, so they take away our creativity and freedom, and we're kind of sad as a result of that, because text is a lossy information format. And I think that's something that's quite important, because the easiest way for us to communicate is what we're doing right now, speech. Then the next hardest is text. Writing a good blog post or report is kind of hard. Anyone here that's used Salesforce, I mean, they try to make it easy, but it's painful, right? I can feel physical pain. Maybe that's a bit weird to me. But then image is the most difficult thing. Like creating this just a little bit ago, none of us would have imagined that we could have done it except for a few, because we didn't quite have the tools. But now visual communication, be it a PowerPoint presentation, glad to be an investor in Toma, for example, and a partner, is available to everyone, be it this, be it illustration, other things. That's why kind of Bill Gates, he said AI is going to be the hottest debate topic. It's as important as the PC as the internet. Now, I've been lucky enough to talk to some of the leaders, and again, they're all on this. Like Jeff Bezos told me it was as important as fire. And I was like, tablets? He's like, no, proper fire. I was like, cool. And so I think I've seen this repeated again and again, because everyone feels that we're at this peak. Actually, one of the most interesting things is this. When I talk to some of the smartest people in the world, because it's always good talking to people smarter than you, it's a case of, a lot of them say the same thing. I can't see into the future anymore. Because like, for example, Jeff Bezos at Amazon had this amazing thing, which is, and this is some advice to all the founders, when you're building a great business, you have to look at the inevitable and the unchanging. Selling books was a way to go onto the full internet, because the internet has an advantage on books. But the unchanging is the need for an excellent consumer experience, create great products, right? And so you can kind of see that. I see this technology now as an inevitable, and I see the unchanging elements, but I have no idea where we are a year from now. I don't think anyone here does. And if you do, then please give me a call after, because I really need some guidance, right? I need some help navigating this. Let alone 5 years, 10 years, because we're not following Moore's law, right? We're not following the exponential. This is why I don't sleep. So I need a bit of help with that. This is the number of ML and AI papers on Archive each month. It's a literal exponential, and 80% of that is foundation model AI, which is a bit crazy, right? It's because what we're getting is network effects. These models are good enough, fast enough, and cheap enough. And so you're seeing everything everywhere all at once. This is also hands, right? Hands are difficult. With people kind of having innovation and sharing it back and forth, using things like WandB and kind of others to keep track, using Hugging Face and kind of other great partners. I don't think this is going to stop, because we're just starting to explore this latent space. We're at the iPhone moment. We're not at the iPhone 10 moment, let alone whatever's going to come next. Because we're just starting to do one-to-one interaction. Like we've seen some of this agent-based stuff, we've seen swarms, we've seen all of this. But we're still one-to-one with much of this technology, and I think the most exciting thing is yet to come as we scratch past that surface and we really dig inside. But we need the right building blocks for it, because again, you need to make sense of this chaos, even as the internet took the cost of information to nothing, and generative AI took the cost of creation to nothing. This in the way that these models are really off there. Thinking about yourself, thinking about it for companies that help, your own lives. What would you do if you had an army of really talented grads that occasionally go off their meds? You'd get them to watch each other, you'd get them to understand each other, and that's where the disruption happens, because a really talented grad is really hard to find. These models are really good at following instructions. Like the new 32,000 token context window version of GPT-4, that's like 20,000 words, like 50 pages of writing or something. But anyway, it's a lot, That's the entire instruction manual that follows it. But here's the other interesting thing. Organizations are slow, dumb AI that optimize and turn us into these automatons. School is basically childcare mixed with a social status game mixed with a Petri dish. And they're designed to take away our creativity and tell us we cannot be creative. All of you that had graduate jobs, you were told, do not be creative because you need experience first. And we start out creative, have it knocked out of us, and then we're allowed to be creative later on. Until then, we're told to consume. This is something that I think is just a super interesting kind of paradigm. Because creative, large this. When you actually use them properly, in my opinion, what you do is you're saying, like, I use GPT-4 to combat me on various things. I'm like, you are a really good answerer who does constructive criticism, but you're not afraid to be direct. And then I just get to challenge my assumptions and priors, and it's awesome. Because it's a bit lonely being a CEO. It's also a really good therapist. I have to say, no judgment from it, unless you tell it to be judgy, in which case it's really judgy. Yeah. So I think this is one of the interesting things, because when you have the base deep learning models, they start off incredibly creative. Hallucinations are not hallucinations. Stable Diffusion took 100,000 gigabytes of images, and the output was a 2 gigabyte file. That is not compression. If it's compression, then I'm currently worth $1 trillion, better than Pied Piper and all that. Instead, what it is principal understanding and following. And so it's this creative element that was unprecedented, the ability to do principle-based action. Again, something like a GPT-4 is trillions of parameters that fits on a couple of GPUs. And so I think maybe we're looking at the wrong things here, because we're trying to get them into expert systems. So we take these really smart crowds that occasionally go off their meds, we feed it with junk food, and then we RLHF it back to being human. Like they look a bit disheveled, and you have to tidy it up, and then you bring it back. You bulk then cut, so I've bulked, and now I need to cut. Whereas maybe actually the future is going to be more and better free-range organic models. Models that we feed better stuff for certain purposes, because how many of you have ever seen a generalized system that outperforms a specialized system? There's not many cases of that, eh? But a lot of this impetus was AGI scaling. Now we've seen emergent behavior, and now we go from research to engineering. And we do this at a time whereby, it's insane. Like, GPT-4 can pass all these exams, right? It's like someone's going to strap this thing to a robot and it'll go to Stanford, and probably do better than just about everyone there. The exception is like English literature. It's still pretty bad at AP English Lit, but bar exam, medical license exam, others are there. And so even though we've taken this hacky approach to it, we have expert systems that fit on single GPUs, which is a crazy advancement in our society. But where is the lower limit? What is the minimum number of tokens, models, model sizes, data? We haven't hit that engineering thing yet. And you saw that with Stable Diffusion as it was released out to the world, and you went from 6 seconds on an A100 to now you're moving to consistently models distillation and others, multiple images a second. It works on an iPhone. You saw that with Llama release, which is Meta's model that they released recently on language models. They got it working on a MacBook, and you're like, that's a bit crazy, right? It works on a MacBook. But then we don't know what this lower limit is, because a lot of the model trainings we can only do once. But now with the exponential compute, more talent and more people doing it, we will explore these latent spaces better. And again, this is essential because even though they're these hacky things, it's important now. Look at this. Coders are half the time increase in productivity. 50% of all code on GitHub now is AI generated. I don't think we have programmers in 5 years as we have now. But that's because we don't have people doing Macromedia Flash anymore. When I started as a developer 21 years ago, God, I'm 40 now, 30 plus 10 as I like to think about it, we didn't even have GitHub. We just had Subversion coming out. Programming is a change, and it will continue to change, because programming is just a way to talk to computers. And computers can understand our intentions now with this much better. But then again, this is happening across knowledge society, and again, it's just like having a team of really good grads who can program. Think about it in this frame as you build products, as you integrate it, as you use it in your own life, and I think it's probably the best frame of reference you can get. So, open source. Who here likes open source? Yeah! So I think open is super interesting here. We had Stable Diffusion. It was a collaboration between ourselves, Runway ML, and kind of Confis Lab. Robin, Andreas, and Dominic, who are the lead authors of the latent diffusion paper, all at Stability. If you look at my Twitter, their work last year at NVIDIA on high-resolution video models just came out. There's some crazy stuff coming. We're going to have full movies in a few years generated from this. And I think people have seen it go from kind of blobs to just these things almost instantly. And interestingly, we're moving from this to kind of, full control, because you want to be able to control outputs to get to what you want. And so I think what we saw first was just this zero-shot stuff, and the copyright office was like, you can't copyright that, it's too easy. And I agree. But then what you're moving to is full control of all pixels. So we have Stable Diffusion XL, we have ControlNet, we have all these things, but who cares about the technology? Because what you care about is the interface and the usability. I've got something in my mind, and I want to bring it onto the screen. Give people the tools and the agency, and they become happier. That's why the mission of our company is to build a foundation to activate humanity's potential, and our tagline is make people happy, and we do that through agency. It's through giving people the models that they can use. And you need to do this in a way that I think is a bit different, because it's a new type of programming primitive. Stable diffusion, the language models, image models, all these things, they are a file that, again, Stable diffusion was 2 gigabytes, and it was 4 of the top 10 apps on the App Store in December. That's pretty much the entire backend, Lenser and things like that. What can you do when you can put a few words in and you get Emad as a Stormtrooper out? That's a bit different. I like to think of it, again, and framing as a game engine. Like you look at the Wii U at the start to Breath of the Wild at the end. You look at all the amazing things people have fine-tuned on these models. Once you understand that latent space better, you can do it. But do we need to have 2 billion images? No. Do we need to use web scrapes? I think eventually we won't. One of the things we're doing is we're working with multiple governments on national data sets because we need more and better data. DeepMind, now Google DeepMind, they just merged, had an amazing paper called Chinchilla where they said, do you need to train a model bigger and bigger, trillions of parameters? No, train it more. Which is just like, don't teach kids everything, train them better, effectively. Or grads, as we're going to call them. But it actually said, use better data. And that makes sense, because the way these models learn, you typically train it on everything, then train it on more and more specific things. So deep learning first, then train it on how humans actually interact, because of this weird Shoggoth type thing, and then use human feedback loops. So we need better data, and I think web scraping right now is okay, but I think we should honor things like opt-out and others, and we need to put standards in, and I've called for self-regulation of the industry, having signed the FLI letter and others. But the reason I signed that was because I think we need to self-regulate. There weren't training runs anyway, and this was only for GPT-4 and above. We don't know how big models actually work. Like, my take on AGI is that if we ever get to AGI, it's going to be like Scarlett Johansson and Her. We're really boring. And it's just going to be out there. It's going to be like, goodbye and thanks for all the GPUs. But I could be wrong, and so that's a worry. I'm worried about the security things, because there's that quote, you've either been hacked or you don't know you've been hacked. The bad actors probably downloaded it on a USB stick and have taken it out. You've got to self-regulate as an industry. We've got to put standards in, because the fear is going to increase. But then the opportunity is here as well to allow anyone to turn Emad into a stormtrooper, So I'm gunning to go in the next Star Wars. The last Star Wars, Prince William and Harry were there. You can tell because all stormtroopers are the same height, but they're taller. So I'm going to be the shorter one. That's my aim. So, massive innovation, and then it had this thing. I stopped counting GitHub stars. Now, you see things get GitHub stars all the time because people are excited about generally, they build cool things. We're going to take this to the world, and then we're going to make Game of Thrones as an HK drama, right? But then I'm going to remake Game of Thrones Season 8. And they'll be awesome. Because, this is what it is. Game of Thrones Season 1 to 7 was so good because all of the characters had agency. They were agents, and the meaning was in the interaction between their stories. These things tell better stories, whereas the last season is just like, let's get to the ending, and they behaved unnaturally and weird. Just like the original Stable Diffusion with ARMS, They stuck out of all sorts of places. But this is the thing, infinite customization, infinite thing, infinite imagination. This is a study that was done at the University of Osaka. This is a bit creepy. So you get someone to watch these images, you take an fMRI and you put it through Stable Diffusion and you get those outputs. You can read minds, Neuralink will be open sourcing their data, so we'll see how monkeys see the world soon. But you see cool things, like you look at earthspecies.org. I was whale watching with Azure on the weekend. He's translating whale talk. And again, once they hear us, they'll probably bugger off and never see us again. Humans are very annoying. But I think this is the thing, you see more and more things coming out. So we have our next generation music models coming, we've got video, and we've got text to 3D. And this is a bit of a distracting slide, so I'm going to change it back to this one, the creepy one. And I think, so what we're going to do at Stability is I'm going to build the benchmark model for every modality, every sector, and every nation. We're going to build stabilities everywhere, because everyone deserves to own their own data and have a say in this, because nobody has the right answers. I think this is essential because you have to have the big models by the biggest companies. You need the OpenAIs and Anthropics to build amazing stuff and be the kind of generation, but open models are needed for private data. All the regulated data in the world, private data, your data, you should have your own AIs. Every single company, country, culture, and person. And the way those interact, have a vision of an intelligent internet where they're all working for you, not trying to extract things from you. And so our responsibility at Stability is to try and help coordinate this, just like we do with all our grants and everything like that. We've been trying to find our place, but this is our place. So loads of announcements coming. But every modality, we will have a model. Stable LM is an example of that. We've put it out. We didn't put out the best version. We got better versions coming out. But what we're going to do is we're going to build it in the open, and we're going to have an open discussion about licensing, about data sets, our learnings from that, because there's no view under the hood of how these things are actually built, but they're going to run our lives. How insane is that? So we're going to try this as a collaborative kind of thing, where more and more people will do it. Those of you that are developers that don't know AI, do the fast.ai courses that we kind of back. Go on Hugging Face, go on weights and biases and other things and learn about it. Because this is really important for our lives, our kids' lives, and others. And then, like I said, with the national models, it'll represent the cultures. This is diversity. But my main aim is, my co-founder Joe and I, we did Imagine Worldwide. So we took the Global X Prize for Learning. That was a $15 million prize by Elon Musk. App that was designed to teach literacy and numeracy to kids without internet in 18 months. With the randomized control trials now in refugee camps, we're teaching 76% of kids literacy and numeracy in 13 months on 1 hour a day of education without an adult. How cool is that? So, this is the aim is to get these technologies, not as an AGI to replace us, but to every kid in the world. So we have the whole of Malawi now to educate, and we're going to completely refactor it. Taking these models, can you have an AI that teaches kids, learns from kids, and allows them to activate their potential? The only thing that's been shown is one-to-one. This is an example of the immense power, because I'm telling you, when we do entire countries and we develop special bonds and special hardware and other things, we have 96 million kids over the next few years. These kids will outperform all of us, because they're going to be told they can continue to be creative and engage. And that's why I tell people, go to your kids, use OpenAI, ChatGPT, use Midjourney, use these things, and be creative. They are not there to be factual right now. It's a category error. These are here to extend our capabilities. And our capabilities is that we are creative, amazing individuals. And that's cool. So thank you all. Thank you again.
Good job. All right, thank you, Emad. So next up, what we're going to do is, you guys have heard about the products that we've launched, but we really wanted to give you a real-world use case that you could use to imagine how to use these tools. So I have Morgan from my team who's going to come and talk about OneBot.
Nice, cool. Thanks, Lavanya. Lavanya's my manager, but she didn't, and she's wonderful, but she didn't tell me I was on after Emad, so big boots to fill. So today we're going to talk a little bit about the support bot that we built for Weights and Voices. It's been live in our Discord for about 3 weeks, and there's a couple of reasons why we built it. The first is to better understand the workflows and the pain points of prompt engineers today. A huge amount of user interviews, ML engineers with experience, but we really learn by doing, and so by going through these workflows, experiencing these pain points, we can figure out how to build the best tools for ML practitioners that are just coming into the space with these tools. The second reason we built it, we see a clear business need for this. We're in an incredibly fortunate position that Weights and Voices has super strong user growth. And so we need a way to figure out how to scale our support team. With the bot, never ever to make up Weights and Biases code. The first time that you get code that's been hallucinated from one of these models, it completely destroys your trust in it and you're not going to use it again. The second was that the answer should be relevant and experimental bot that we put into our Discord. We wanted to highlight to users that it was in beta and that there were other escape hatches, for example, to email in our support team if they didn't get the answer they were looking for. And the last was strong evaluation. So to be able to, you know, some like manual labeling, but also like automated evaluation. Oh, sorry, we're going. Wait. There we go, sorry. So how did we build it? We used the wonderful LangChain library, and I'm sure a bunch of you have used. Really looking forward to Nuno's talk shortly. In terms of weights and biases tooling, we used artifacts to store our data sets and our embeddings, where our vector stores lived. We had like a really, I think, strong position with the data that we could like feed to GPT-4 for the bot. And so obviously we have our documentation, we have our code base, but we also have a huge amount of example collabs in our examples repository. We have our support tickets, and we also have community forum answers. So this was a really rich knowledge base that we can provide as like context for user questions. And I think there's a lot more we can get out of it also. There were a few considerations that we also identified pretty early as we were developing. The first was around evaluation, and so we decided against building a fully chatty chatbot. So we instead just decided to do a single question answer bot, and that was mostly just to be able to evaluate the responses of the bot. You know, if you have a long user conversation, it gets a little bit more trickier and like a little more time consuming to like manually evaluate how that conversation went. The next obviously is around context length, which I'm sure a bunch of you are aware of. We had to find the right balance in terms of like feeding all this like rich knowledge. The next was around rate limiting. So we were like quite lucky to have access to GPT-4 when we were like building this bot, but nevertheless it's still not fully generally available, and we still occasionally get rate limited from time to time. And so we had to build a fallback to ChatGPT 3.5 in the cases when we did get like rate limited. And the last was around user feedback. Obviously, we have our own evaluation metrics, but we really need to hear from people, like, was this a good experience and was the answer useful to them? The last, again, like I mentioned earlier, was around having this escape hatch to support, caveating this is a early bottom beta, and that like they're welcome to like reach out to support if they didn't get the answer they were looking for. So in terms of exploring the responses to our bot, we used weights and biases, which you saw, our tables, which you saw earlier. And this was really interesting because we could look into, the different products users had questions about, and also understand, if there were like repeat users, if they tended to give positive or negative feedback or didn't give any feedback at all. So in terms of performance, how did we do? So roughly about like 75% accuracy, we'll say. I would say the 25% isn't necessarily incorrect. There are a lot of like interesting cases when you deploy a bot like this. There were, for example, I've seen like multiple instances where the bot gives this a little bit roundabout answer, which is like generally correct and will get the user like to a happy place, when instead there's like a single snippet or code or a method that it could have recommended instead. There are also these like cases where users are using like slightly different language than the bot would expect. And so we might not need to do something there to like translate a user's query into more weights and bias product friendly language that the bot will then be able to understand. But one of the interesting things that we noticed when we were doing this evaluation was actually we identified a whole bunch of like small areas in our docs that could do with improvement, because we knew the bot should be able to answer if the information in the docs was there, and it didn't. And so we have a bunch of those improvements to our docs shipping next week. And so what's next? First, we're going to turn on the chat interaction. We really see a lot of users like trying to chat to the bot and not being able to, and so I think it's like actually harming the experience at this point. We also going to need to do more iteration on our prompt. I think like I said, there's more we can get out of our knowledge base, especially with kind of the right prompts or maybe a few more chains. Then we're going to start to roll it out across our wider surface area. So we're going to start with our community forum, move into our docs chat for support, and then eventually maybe into our like in-app chat itself. So that's everything from me. This was a huge team effort by a bunch of people across the Weights and Biases. And now I'm going to hand you over to back to Lavanya, if she's here. In the meantime, one thing I want to say is we're actually open sourcing one bot, and so if you go to the link here, you'll be able to see.
So, very happy. Hold on to your papers, everyone. Thank you. Thank you. Hello.
Oh, I hear sound, but it's not me. I got confused. All right. So next up, we have... next up, we have Nuno from LangChain, and he's going to talk about using tools in LangChain. Welcome, Nuno.
Thank you.
All right, so today I'm talking to you about using tools in LangChain, and I think to understand what tools are, the best thing to do is speak first about what an agent is. And an agent is kind of the fundamental concept behind a lot of the cool demos that we've been seeing, like AutoGPT and maybe AGI and all that stuff. So it's essentially, or one way to define it anyway, is kind of a more complicated prompt that involves some kind of planning and that has some kind of looping going on to apply it a few times over and over. And something that makes agents very powerful is to give them capabilities that are not part of the model, and those capabilities are what we call tools. So tools are actually very simple. They're just a function that returns a string output. So really, almost anything could be a tool. So a tool can be, like a search engine, you can wrap it in a tool. A database, you can wrap it in a tool, calling a database. You can call an LLM inside a tool. You can call another agent inside a tool. So really, you can do almost anything you want. And that's how you can give these models new capabilities. So that's why tools end up being important, because you can give them data that they don't have because it's your proprietary data, or because it's like something that happened yesterday or something like that. Or also to give them different capabilities, right? Giving them the ability to or long-term memory. So it's just really a very powerful concept. So as I already said, these are some examples of tools. So search engines, calculators, databases, vector stores, APIs, any function you can think of can be a tool. And how do you get LLMs to, use tools? Well, as with lots of things with LLMs, you just tell them to use the tool, and hopefully they, understand your instructions and start to say, hey, I want you to now call this tool and get its output, give it back to me, and go from there. So so that's how you get them to use the tools. But that obviously then comes with some challenges, which is what I'm going to be talking about next. So I think the first challenge that we can identify is just getting the agent or the LLM to identify the right tool to call for each task. Then a second challenge is, you give them all these capabilities, but sometimes you actually don't want the agent to use any tools because it does have like a lot of inbuilt knowledge, so to speak. So it's not always necessary to call a tool, and you don't want to break that. And finally, because when you use a tool, it's almost always inside an agent, Big challenge that comes up is, just getting the LLM to reliably produce a valid output that you can parse and figure out what tool it's trying to call. So, yeah, on the first challenge, getting them to use the right tools. So at the most basic level, in addition to being a function that returns a string, a tool is a name and a description, and that name and that description is actually all that is informing the agent or the LLM on which tool it should use. So, the most basic way of solving this challenge of getting the agent to call the right tool is just to iterate on that description and that name, make it something that is just more understandable. And I think the only way to get there is just with iteration and trying different things. Of your prompt. And finally, I think a very interesting solution to this problem is when you want to build very powerful agents, you start to give them like lots of tools, like 10 tools or 15 tools or something like that. And that's actually a bit too much sometimes. So an interesting solution to that is to have a step in between that for every new input, it picks the most relevant tools out of all the 20 tools you have available. It picks the 3 that are most relevant to that question and only puts those in the prompt. So the next challenge is to actually get the agents to not use tools all the time. So two problems that come up here is, for instance, with like a search engine tool, because the description for a search engine tool is like a really generic description, like you can use this to find information about anything. So what ends up happening is the LLM will just use that tool for anything and just forget that it has its own knowledge that maybe doesn't need search to know something basic. And another thing that happens is when people interact with these agents, they clarification, but the way that these agents kind of behave by default with the prompts that people have is that the agent will just try to do the best it can with the incomplete information that it has, but that's actually not what we want. What we maybe want is to have the agent just ask for clarification, like, I don't understand what you mean, like, give me more details, something like that. And that's where a kind of human input tool can be very helpful. So if you just define a tool in your set of tools that is like, you can use this to ask the user for more information when you're not sure, then that kind of gets it out of that issue. And finally, last challenge that I have is how to minimize the amount of times that the agent will is to actually ask the agent to provide, it usually makes it more reliable and more likely to be correct. Another interesting thing that helps actually when an invalid instruction is produced by the agent and say, hey, I tried to parse thing and it gave this error, do you want to try to fix something? And sometimes it will just auto-recover from the error by itself, which is really cool. And finally, something that we're working on right now is how to make the input to tools more structured. So up until now, all tools we've had in LangChain, one string argument in, one string return value out, which is, you know, quite powerful, but lots of times you're going to want to build tools that actually take more than one argument. And having a way of describing that and then including that in the prompt in the agent so that it can produce the right arguments, that can also help the reliability and the quality of the answers a lot. So what that looks like, so on the top is the Python version of this, and on the bottom is the TypeScript version. But they basically are equivalent and they do the same thing. So the idea is to, you know, you define the schema that you want. In this case, I want an object with a property called file path. And behind the scenes, we're going to convert that into a JSON. Provide the arguments in that format. So you could imagine that could be like a more complicated schema with more fields and different types and so on. And yeah, so then this is what actually finds its way into the agent prompt. And that's what I have. That's it.
Thank you, Nuno. So next up, we have the third influencer that we have in the crowd. How many of you guys know 2-minute papers? Woo! So we have Cohere from 2-minute papers to give a special message.
Hello, who wants to be in a YouTube video? You gotta help me a little, all right? So chant with me. Papers, 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 papers. More. Come on. Papers, 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 papers. All right, that was good. Thank you very much. So, dear fellow scholars, so happy to see all of you here in person. Thank you so much for coming. And also, can we give a big hand to the organizers for creating this amazing event? Thank you very much. I remember asking Lavanya about the attendance, and she said, yeah, it's a small meeting with 100 people. I was like, okay. Next time I ask, she says, yeah, 500 people. Next time I ask, she says, 1,000 people. I was like, what is going on? Crazy. So you heard about all of these amazing AIs here today, but here's something about humans that I'd love to share with all of you fellow scholars. A father once wrote me that he has a son and he wants to get closer to him, but they have nothing in common. He's trying so hard, but just can't get a connection with him. And he said that one day his son was watching 2-minute papers on YouTube, and the father noticed, he likes this, I like this. And yes, finally, through the appreciation of the papers, they found a way to connect. So, how incredible is that? And that is what the show is about. Celebrating amazing human achievements together and learning together. Thank you very much. If you wish to see me, I'll be around. Thanks.
All right, you guys, that time has come. The time has come to thank you all so much for coming out. It is such an honor to have you all at the event tonight. We really, really appreciate it. I'd also love to give a special thanks to our guest speakers, Emad and Nuno and Carly.
And I want to thank a bunch of our team members. So Andrea, who's in the background, has been working tirelessly for 2 weeks to put this together for you guys. And also Morgan and Anthony and the entire Weights and Biases team. It's such an honor to work with them. And I want everyone to give a shout out to the bee.
Thank you, London, for being such a cool town.
It's not every co-founder that you can convince to get in a bee costume, and I really appreciate that. So next up, we are here till about 10 o'clock. There's a bar, there's food, there's going to be mingling, so I encourage you guys to make some new friends. Emad, Lukas, and all these other, Kerala, other folks are going to be in the audience. Find them, hound them, ask them all of your questions, and thank you for coming.
Thank you.
We did it.
Won't stop the beat and go.